Thank you for coming to our poster. My name is Dakota Murray, and I will be sharing our team's work. This project began with a seemingly simple question. How far apart are two places? This simple question turns out to be surprisingly difficult to address. The natural approach is that the distance between places is a matter of their geographic distance. However, in a highly connected world with airplanes, trains, internet, and international trade, geography may be less important than their cultures, economies, and languages. Here, we present an approach for learning a functional distance between places directly from human mobility data using a neural embedding model. We demonstrate this approach using the case of scientific mobility, a complex case study with deep consequences to innovation and research policy. Using data from the Web of Science, we construct mobility trajectories for individual researchers using affiliations listed on their publication records. That is, each trajectory is a list of affiliations ordered by year of publication. We use these trajectories as input for the neural embedding model Word2Vec. This model learns a vector space representation of scientific organizations. Here, each organization is represented as a vector, and distance between vectors, measured using the cosine distance, maps to their tendency to appear near together in the same trajectory. This distance is what we refer to as an embedding distance, and it can serve as an alternative to geographic distance. We can assess how well the embedding distance performs relative to geographic distance by comparing their effectiveness in explaining real mobility flows using the gravity model of mobility. This is a simple and intuitive model that considers mobility flows between places as proportional to their sizes and as a function of distance, similar to Isaac Newton's law of gravity. The embedding distance outperforms geographic distance in explaining and predicting real-world mobility flows. Here, in the first set of plots, we show that the embedding distance explains more of the total variance of real-world flows than does the geographic distance. And in the second set of plots, predictions made with the gravity model and embedding distance outperform those made with the geographic distance, with predictions more in line with actual flows. But what is actually being captured in this vector space? To explore this, we project the entire vector space onto 2 dimensions using UMAP. The global projection in panel A shows that organizations are mostly clustered by country and roughly arranged according to their geography. For example, the Indian cluster is close to the South Korean cluster due to the high exchange of scholars between them. But there are also exceptions to this pattern. Organizations in French-speaking Quebec, for instance, are nearer to the France cluster than to their own Canadian cluster. We can also reproject a subset of organizations for individual countries. Panel B reveals a gradient encompassing geography and culture that stretches from Egypt to the Philippines. Doing the same for Central and South American countries reveals the importance of language. Portuguese-speaking Brazil is positioned near Portugal, whereas other Spanish-speaking countries are instead positioned near Spain. The embedding space also encodes structure at multiple scales. For example, projecting only organizations in the United States reveals another level of geographic clustering. Unique structure is revealed when projecting at the state level. Here, we project only organizations in Massachusetts. These organizations are split mostly between the cities of Boston and Worcester. But the University of Massachusetts system, a public university system with a focus on teaching, constitutes its own cluster, apart from the other more research-focused universities. We observe this or a similar pattern for public university systems in Pennsylvania, Texas, Florida, Illinois, and California. In conclusion, we outline a data-driven approach that encodes geography, language, and prestige at multiple scales into a vector space representation that is high resolution, dense, coherent, and meaningful. Distance in this space also serves as an effective alternative to geographic distance for many tasks. Thank you for listening. If you want to learn more, reach out to me through email or Twitter using the information listed on this poster. In the meantime, stay safe and enjoy the rest of your conference.